And let me see if I can get rid of this before I try to explain you how email works, which is kind of a daunting task. There you go. Email me maybe. So I'm Pedro Coelho. I'm a software engineer. I'm the CTO at Cleverly.ai, which is a company that does AI for customer support, namely email. And I had my own email server for about 3 years, give or take. And when I say my own, I don't just mean the domain, I mean the domain, the server, everything. And in this small presentation, I'm going to try to explain you the basics of how email works, the technical side of it. We'll try and set up a small server live in record time, just so you can see how easy it is. I don't want you to feel pressured to understand exactly every detail of what's going on, just more like a demonstration. And then we'll go into one of the most important topics if you're going to do this, which is spam, which most of you think it's a solved problem. It's not. Tools just became very good or good enough so you don't have to suffer with it anymore. So let's start with the basics. Addressing. Who here has never seen an email address? Yes, as I expected. Good. So we've got the @ sign, and at the left we've got the username or the virtual username or the name of the person that has that email. This historically would be the username. And at the rightmost side, we've got the email domain, which historically used to be the host name. Back in the days, people would log into a mainframe at their university. They would have a user assigned in a host, and that user at host pair would be their email handler. So this is historical. It's not like this anymore. Neither of you have a user address at Google or at gmail.com, and yet every one of you has an email. But this was how it was. So email, let's start with the three-letter acronyms. Three-letter acronyms are something that operations people and system administrators love, because they make everything look so cryptic, don't they? So the MTA is the basis of all email. It's a mail transfer agent. So basically, all email in the world, email is just a network of mail transfer agents. And each mail transfer agent is responsible for a domain. It gets more complicated than this, but let's not dwell into details. This is the basics. So the language they use to talk to each other is SMTP, which most of you, if you ever sent an email or configured Thunderbird or used SendGrid to do something, has heard. And some examples of this software is Postfix, SendMail, or Exim, just for reference. Then you've got the MUA, which is radically different than the one before. It's the mail user agent. This is the program that you use to read your email, such as Thunderbird or the Gmail app on your phone. This is the MUA. And then there's the MDA. You see that all acronyms are very different from one another, don't you? This is the mail delivery agent. This is a program that runs alongside the MTA. We'll see. We'll have kind of a visual representation afterwards. Don't be alarmed. And it grants you access from the outside of the server to your inbox. Now, this is something that people don't use in the desktop anymore nowadays because there's web apps for this, like Gmail and such. But you still use this when connecting your phone to your email at work, for instance. So you still have to configure IMAP 4 or POP3. These things should ring a bell to some of you. So let's put all of this into perspective. So when you send an email, there's you at the bottom left corner, and you want to send an email to example@gmail.com. Please pay attention to this because it's important that you know that you're sending an email to example@email.com. Don't forget example, right? Example is important because Why would you send an email if you don't know who you're sending to? So you're writing your email at your MUA, which is in this case Thunderbird, and you press send. Thunderbird will connect to your own email server, which is what we'll set up next. We'll connect to it via SMTP and relay the message. Your MTA will look at the message and see that's a message that's addressed to gmail.com, someone at gmail.com. And it will ask itself, am I gmail.com? It runs into a small existential crisis until it realizes it's not. It's sneakermail.net, right? So who handles Gmail? Who handles gmail.com? Who should I deliver this message to? He asks DNS, and DNS gives the server back. This is an MX record. We'll see how useful it is in a bit. Your own server then connects to Gmail's postfix, Gmail's MTA, again, speaks the same protocol as before, relays the email, and the postfix at Gmail goes into the same existential crisis as before. But this time, it will see that, yes, I am in fact responsible for gmail.com. So, as you send the email to example, it will search example within its users and will deliver the message to its inbox. Now, if you realize this, if a message were to be sent to you, it would be the exact same behavior. Your postfix would get the message, it would see if it's sneakermail.net, and it would deliver the message to the corresponding mailbox. So this is what happens when you send an email, and this is the basis of all email communication on the internet, this type of interaction. Now, a most common interaction that you might have seen is when you check your email, when you check for new messages. And here is where the MDA comes in. The MDA will grant access to your Thunderbird to your own mailbox. So when you send email, you talk directly to the MTA, but when you want to check your messages, you talk to the MDA. That's just it. So, anybody has questions? Has anybody has any question at all? Any remark, any comment? Am I speaking too fast? Am I speaking too slow? All good. So let's get started then. I'm going to try to configure an email server on the fly. And by the way, I encourage you, and I'm speaking very seriously about this. This is a non-working email address, but I'd like you to send an email to this as soon as you can. It's Pedro at sneakermail.net. It might get you a bad response, but if all works out, we'll see your emails arrive in the server that we'll be configuring now, hopefully in record time. If it doesn't, well, we'll just get a small lesson about spam, which is nice as well, I guess. The email is down below. If anyone has difficulty seeing, please let me know. So, based on what we saw, we absolutely need a domain to make this work. So get yourself a domain. I got mine. We'll need some domain records to make this work as well, namely an MX record, which was the record that DNS responded when our server asked who was responsible for any email. And we need a PTR record, which we'll see its usefulness later. We'll need a VPS, a virtual machine. Shared hosting will most definitely not work. So, and we'll need some patience, a cold beer, a tea, or a coffee, or something to get on this. So if everyone's ready, let's look at the very dark terminal for some time. So I've already set up a domain name and an instance on DigitalOcean. This is my experiment. This is the original instance, as you can see. And on my domain, I've set the MX record pointing to a host name here. And that host connects to an IP. That's it. Never mind this part below, it doesn't really matter. And hopefully I'll connect. This is when things get wrong. Oop. Just a second. No internet, right? Let me try something real quick. Ah, there we go. Can everyone see? Okay, first of all, good practices. This is an empty server. It has nothing. It has a couple of users, but it's really not important. Try not, if you ever do systems administration, try not to do a bunch of things that I'm going to do, which is, for instance, work as root, but never mind best practices. We'll just get the show on the road. So we'll start by updating our sources. Again, this is for demonstration purposes. I'm going to show you how this is done. You don't need to learn any of this. You just need to feel the gist of it and how parts interoperate. And why is that? Because this is very simple to do. We should be done in about 10 minutes. But you don't need to do this manually nowadays. You've got a lot of drop-in solutions for this. Mail in a box, for instance, if you search on Google for it, is one of those things. You just run a Docker command and you're all set. Probably have to set some things on a configuration file, like your domain name, and you're done. So I'm just going to show you how parts kind of interact, and hopefully we'll see this work just to demystify how hard this may look, because it's really not. So we'll begin by installing our software. Which is Postfix, our MTA, 2 email clients, and Dovecot, our MDA. So it'll ask you to configure internet sites. It'll ask you your domain. It'll take a bit. Hopefully not as much time as I anticipated. If anyone, this might take a while installing some of the stuff, so if anyone wants to do any questions, just ask. No questions?
I'll think of some. Why do you don't run your email server anymore?
We'll get to that. It's the last slide, I promise. So, software is installed. Now, we'll be running a command called postconf, which will configure Postgres. This is the same thing as editing this file. But it makes some verifications when I run it, so I'll just run it. So this first command basically tells Postfix its identity. It solves the existential crisis that we've seen before. Are we sneakermail.net? Yes, we are. Next set of commands will tell Postfix where to store the email, and it'll store in a mail dir on each user's directory. Next thing we'll do will be to get certificates using Let's Encrypt, because nowadays it's terribly easy to do this, and there's no reason to have your servers unprotected, let it be mail or HTTPS nowadays. You don't need to buy a certificate, you just need to run a couple of commands and you're done. And the command is this. Maybe postmaster. Yes, I agree with the conditions, and yes, sure. Verification. Good. So we're gonna connect that. Well, that's weird. Oh, yeah. Don't do this. Okay. All right, got our certificates. Now, we'll tell Postgres where the certificates are, which should be MX, which should be here, right? That's what they gave us. We'll tell Postfix how to use the certificates that we have them. And we'll tell Postfix not to accept any, this is all gibberish, but what we're saying is how to use the certificates, how to encrypt the connections, and how perform authentication to people that connect to the server that want to send a message. This is very important, and as we'll see next when we talk about spam. Next, we'll just run a couple of commands to enable virtual aliases. And virtual aliases are kind of cool. You'll see what they are as soon as I'm done with this command. Basically, you can map any sort of left side to a user you have on the machine, which is useful because I don't want to create a user named info. I can just receive them on my Pedro mailbox. And then I run a post map here, which I need to. We'll be ready to restart Postfix. Now, this configures our MTA. We're going to need to configure our MDA real quick. This will create the folders draft, send, trash, and templates for all users that we create from now on. We'll create a user to receive those emails called Pedro and give it a password that I'm going to type. Good. We'll create all folders on Pedro's home dir and add it to the group mail, which is a necessary step, but this is more administration than anything else at this point. And we'll tell it to use the mail dir that we established before to fetch the messages. And now we just need to configure a couple of files from Dovecot, which is the program that will allow us to get our messages to be done.
Did you just change your root password?
I didn't. Did I? Oh, I did. You're right. I shouldn't have done this because no password is better than. Thanks for that. Stuff would not work and I wouldn't be knowing why. Good. Now we'll just, sorry. This is not good. Just a second, okay. Now we'll just give a couple of defaults here. Now, Dovecot controls access to your mailbox, and since you're accessing your mailbox from the outside, it also performs authentication when you try to access stuff. So this is responsible to get your password. And what I'm telling him here is you may use my login on the machine to validate me as a username password. So the username Pedro and the password that I've set before for me and apparently for the root user will also work for logging into my email. So this is done. I will tell now Dovecot where the messages are stored. Should be in mail location. It should be down below. Here it is. So comment this out. Mail location. So it's a mail dir format at mail dir. Is it? Yes, yes it is. Hopefully it'll be fine. Maybe I'll copy paste to ensure success. Okay, looks the same. And now we'll tell Dovecot that we want to enable IMAP, not POP3, but out as well. Just a second. This is all very cryptic. And finally, we'll tell Dovecot to use our certificates. Oh. That we'll tell them that SSL is required, and we'll give Dovecot the location of the certificates that we had before. This is wrong. It shouldn't be here. Okay. Should be good. Okay. Now, hopefully I might have received some things. So you see there's a mail dir here. You see that, okay. You see that all emails will be stored as files here. And maybe we'll be lucky, maybe we won't. Let's see. I'll just configure MUT, which is a mail client, real quick here. You don't need to look even. Just copy, paste. Oh, okay. Oh! Here, we received an email from Rodrigo Torres at gema.pt with a smiley face. So our email server is working. Just a second. So after some painful 10 to 15 minutes, we got an email server working. So it's good. It's not that hard. You see that I was following a script, copy pasting all those commands. But you see there's really no big deal in getting you to receive email on a server of your own. Now, sending email, however, that's a bit of a different story. And why is that? Because of spam. Spam is a global atrocity, and whoever deals with an email server knows about that. We've all been actually shielded, pretty much shielded from it from the last years. I mean, who here has received an old-fashioned spam email like the Nigerian prince scam or something about Viagra or Cialis? Who received here an email like that in the last year? Yeah. Okay, 3 people. We are shielded from that because Gmail and Yahoo and Microsoft have been doing a tremendously good job at shielding us from it. But these are actual stats that, well, Secure List and Spam Laws gave it to me, but if you look at them, you'll find several sources with convergent numbers. about 52% of all email is spam right now. In 2008, 92% of all email was spam. And maybe we're better than we were before in percentages, but if we see that in 2008 we were 1.4 billion internet users, and now we're 4.3 billion, almost 3 times more, you'll see that in absolute terms, spam is still a huge issue. Spam harms users because most spam is harmless advertising trying to sell you pills to do impossible stuff, but most of them are scams and false advertising. And an even smaller chunk, but still considerable, is phishing, which uses scams to get your credit cards and so forth. So it really harms people, besides viruses and worms. It actually harms providers as well because, well, let's look at the math. If you have infrastructure to process email, and the processing of your email, if your Gmail, and if the processing of your Gmail costs 10,000 euros, and you're processing, and 52 of that is spam, then you've just spent 5,200 euros just processing junk mail that will harm your users. So naturally, companies are not interested as well in processing these kinds of emails because infrastructures cost money. So how do spammers spam? Well, they start by creating their Gmail accounts and spamming everyone, but Gmail quickly shuts them off. So they turn into doing what we're doing and getting their own servers. But again, they are quickly blacklisted. And finally, they try to piggyback on other people's servers, which means they try to connect to your unprotected server and try to send emails on your behalf. So you've got to protect yourself and others if you want to do an email server of your own. You got to disable the open relay, which was what we were speaking about before. You need to enable authentication on your MTA to prevent spammers from sending email. You need to make your server trusted by doing 3 things that we'll be speaking about. To Gmail's eyes, you need to be a trusted party. Your server must be a trusted source of email, or else they won't accept your emails. And then use a PTR DNS record. What's a PTR DNS record? It's a reverse pointer. You'll give it your server email. DNS works like you give it an address and it gives you back an IP. And the reverse DNS, you give it an IP and you get an address back. So it's like a verification. I got this from this IP. Is this IP this server that's contacting me? Yes, it is. And then there are weird shenanigans that are represented by those 3 interrogation marks at the end. We'll see about those. So we'll start with SPF. This is something that you absolutely need to configure to be able to send emails to Gmail accounts, for instance. SPF is an acronym for Sender Policy Framework, and it's a DNS record that you have to put on the DNS domain name that you will use as your email address. It's not that hard. It's just configuring a text type of field with one value that's similar to the one below. It'll basically tell other servers, other MTAs, that the servers that are allowed to send email of that domain are represented as those IP addresses. So when your server, which is sneakermail.net, with the IP 12345678, talks with gmail.com and sends a message, gmail.com will ask your DNS if that IP is authorized to send emails on the behalf of your domain. Your DNS will respond with that record, and you'll see that this IP must be the same as this one below. Or Gmail will refuse your message. So this is the first step. If you don't have the SPF record, Gmail will be suspicious. If you have it, it's a point in your favor. Next security mechanism is DQIM. DQIM stands for Domain Keys Identified Mail, and ensures that your server was the one that sent the message in the first place. Well, it uses by using asymmetric cryptography. Who here knows how a public and private key pair works? Okay, who here doesn't? Okay, this is a pretty clear representation. In asymmetric cryptography, which is a huge name for a thing that's really simple, you have two keys. You have two keys that you can scramble text with. You've got a private one that you should keep for yourself, and you've got a public one. So you've got a message named hello. You scramble it with your private key into something that's unrecognizable, and then only with the public key you can unscramble it back. If you use the private key, it's not going to work. And what will that tell you? That tells you, when you unscramble something with the public key, it will tell you that it had to be scrambled with the private key. So if this belongs to a single person, and you get this and unscramble it, you know that that person did this, right? Makes sense, because there is no other key that can do that. So the idea of the DKIM is to store your private key in the server and store your public key on the DNS. That way, and each email that goes that goes out of your server will be signed with that private key. So Google, when receives an email, fetches your public key from the DNS, because it's public, it's published to everyone, and checks if the signature matches. If it does, only that server could have sent the message. Make sense? Good. Because this is a pain in the ass to configure. But we'll do it regardless.
Why would you need the SPF if you have this set in place?
The SPF, it's more like of a policy thing. You're telling Google about a set of IPs that are authorized to do that. You can remove, yeah, and you can remove IPs from the SPF, thus invalidating whatever comes, if it's signed or not. But to, to configure Open DQIM, well, I'm not going to do that now. Maybe later. Because I don't sense you guys are very into that right now. We'll just finish with this and see where this goes. Finally, there's DMARC. This is a fairly new one, and this is more like a compliance kind of thing than anything else. It won't verify anything, but it'll tell other servers what to do when messages get rejected or deleted or something doesn't pan out. It looks like the record below. We'll see how it works. So Gmail just received a message from you and checked DQIM, and it's invalid. So it wasn't sent by you. So what does Google do with it? Until DMARC was invented and out in the open, it would be up to the server's administrator to do whatever. But you might want to know that. You, as the owner of sneakermail.net, might want to know what funny business is going on with your email, or what hackers are trying to use your email to send emails on your behalf. So DMARC comes to solve that. Not only will it tell Gmail what to do when a message doesn't check out, such as rejected or quarantine it, which will be marked as spam, and then delivering it with a strong indication that it's suspicious. It'll also send you back reports on weird stuff that happens. So if you're being attacked by some hacker that is trying to use your domain to phish people, at least you'll be alerted about it. So you'll need all those three mechanisms so that to get Gmail to trust you. And finally, there are blacklists. Beyond all those mechanisms, there are blacklists of IPs that were known to spam before. So if your server happens to have one of those, you're boned. There's really nothing you can do besides getting another server with another IP and see if that IP belongs to a blacklist or not. So before you even attempt to configure your email server, let it be with my method or mail in a box or other solution, you should really see if your IP belongs in a blacklist. There are tons of sites, I can give you a bunch, that do this verification for you. Now, there are another caveats about owning your email server, particularly on Google Compute Platform. They don't allow outgoing SMTP, which means that this scenario here, where your computer speaks with Google, your hosting provider won't allow this, which will make email automatically not work. Some do this to control spam. Google Compute Platform does this. The Faculty of Engineering of the University of Porto started doing this a few years back as well. And the solution is to ask them for an SMTP server of their own. They usually let you have a server that you can relay messages through. So it's kind of a third server that only passes messages through, but they control it so they can close the faucet on you whenever they please. It actually makes things easier because that SMTP server is not blacklisted and is usually trusted. So it's not that bad. Also, as soon as you configure your email server to send messages using all these mechanisms, you should check your score on these sites. They will tell you what's missing. They will tell you what you have right and what you have wrong. This is really important before you start doing regular email communications with your server, because if you don't get a good score here, you'll probably won't be able to send any messages to anyone. You'll be able to receive them, as we saw before, easily, but you won't be able to receive them. And finally, there's the weird zone that I spoke before, the 3 interrogation marks, which is companies have motivations. They don't want to harm their users. I mean, they don't want to lose money, right? So a great deal of hosters, like Gmail and Yahoo and Microsoft, they turn to whitelists instead of blacklists, which means that instead of just going after the IPs that were known to have spam before, they keep a list of IPs that they know they're absolutely trusted. So if you're Gmail, you're probably going to keep a list of IPs of Microsoft servers, of Yahoo servers, and other big email providers. So you know that emails that comes from there are controlled. But that harms us, because our IP won't be in those whitelists. And if it's not, there have been evidence over the years, or at least strong indication, that they have been flagging emails as being suspicious from sources that are not on their whitelists. And that brings to the question you asked before. Why did I stop using my email server? Because I started seeing that. I started seeing that mails that I sent to Gmail, for instance, some were there, some weren't. And although my score on the URLs that I mentioned before was perfect, although I didn't show up in any blacklist, mails weren't being delivered. And I even saw, I tried to find it, but I wasn't able to. I saw in the heading of an email, because an email has headings like an HTTP request, an annotation by Google saying that this email is suspicious because it doesn't come from a trusted source. So if you really want to own your email server, be wary of that. Also, the landscape changes quite often. So if you're thinking about setting up a server like fire and forget, and in 5 years it will be working just the same as it is today, it probably won't. Because DMARC is very recent, and DQIM is something that appeared like 10, 15 years ago, like widespread. things will change, your messages will be lost, and we haven't even started to speak about receiving spam, which is a huge deal of, which will be very, very, very annoying, because believe it or not, there's a ton of it, and it's so old. It's the Nigerian prince. Who here hasn't heard about the Nigerian prince? The Nigerian prince is an email that is sent to you about a Nigerian prince that's in distress. He needs to ship $10 million out of Nigeria, but he doesn't have a foreign bank account. And you were chosen to get that money. He will give you half if you do that. That's something that's like 15 years old and people keep sending it, and it becomes an annoyance. Yeah, I hope you guys have found this, you people have found this interesting and elucidating. Thank you for your patience, thank you for watching. And if you have any questions, I'll keep this email up. So if you want to send any email, I'll read your messages and reply, I promise. Mail may not arrive, but sorry. But that's it. I hope you guys, I hope people enjoyed that. Right on time. Thank you.
Could you respond by email, just to see if it arrives?
Oh, it won't, but I will respond to a message, and you'll see it appear on the spam folder. Look, it's all here. Mail is wonderful, right? So, open mailbox. Oh, mail. What email do you want me to send the message to?
It's Studio.
Studio.
Rodrigo Torres.
.net. Good. There you go. Check your spam folder. It's probably there. Let me just...
Maybe it arrived later.
Set. There you go. So you're using Google Apps, right? Yeah?
Yeah.
I know that. See? This is your MTA, right here. Well, it's sent, but it's probably flagged as not interesting because none of the SPF and DKIM or DMARC has been set up. So it's probably not there.
This is from the email client.
Oh yeah, there was, I actually had, what? Thunderbird here. Yes, I actually have a Thunderbird here. So let me see if I can very quickly deploy an account. So let's add an account. Add mail account. The password is the one I've set before, hopefully. The host name we set was MX. Username retest. Ports, start TLS.
There you go.
Spam?
No.
It's there?
Yeah.
Oh, that's very good. I'm surprised myself. Well, don't do this at home then.
I know that now that I sent it from my Google Mail account, but this one is not.
I see. Well, for some reason this is not working. Sneakermail.mail. Application. Oh, oh. Well, for some reason this is not working, but maybe the password is wrong. Nah. Oh. See, there was an error in the configuration.
I thought it was weird that you took out these characters, but I thought it was correct, so I didn't say anything.
All right, sorry. File. Line 12. This is not according to my... Well, it is. Yeah. I wonder if it's here. Which ones? Oh, maybe it's that. Maybe it's that. Yeah,
The example line doesn't have a notation.
yeah, maybe it's that. It worked, I guess. Okay, that was it. See, all works. And now in 15 minutes. So don't let me, don't let this all talk about spam disencourage you, and at the same time, don't let the talk about how fast this was encourage you. So there are trade-offs about this, but if you want to do this, it's a fun project to do. And again, if you want to send me an email, please do. Thank you once again, and let's eat.